right, so here we are. This is lesson number 5 for Math 15, Introduction to Exponents. Now, hopefully this isn't a total introduction, but today we're talking about exponents, and then we'll be talking about order of operations. We've done adding and subtracting integers and adding and subtracting fractions, as well as multiplying and dividing integers and multiplying and dividing rational numbers or fractions. And now we're going to talk about exponents so we can understand how they work and clarify anything about them. And then later today we're going to talk about order of operations, where we put it all together. Okay? Now, exponents are really an abbreviated form of multiplication. For example, if we have 4 to the 3, that's the same as 4 times 4 times 4, which equals 64. So what we're doing is we are expressing this multiplication of 4 3 times in a more condensed way. Okay? So we have 3 times we're multiplying 4 times each other. So that's what that little exponent tells us. Now, if we break down a power, so this whole thing is called a power. The 4 is our base, and 3 is our exponent. Okay? So the power is an abbreviated form of multiplying a number, a number by itself. Okay? The base is the number we are multiplying. By itself. And the exponent is the number of times we multiply it. Okay? So hopefully that kind of clarifies it. Now we have different things. We could say this is 4 to the power of 3. We could say it's 4 to the 3rd power. There's different ways to express that, or we could just say 4 exponent 3. Same way of saying exactly the same thing. So let's expand and evaluate the following to see how exponents work, because there are some tricky things, particularly when it comes to including integers in the base. When we have negative numbers, it's going to change things. So 4 to the power of 2 becomes 4 times 4, which equals 16. Now here, in the second one, we have negative 4 to the power of 2. Now there's no brackets around the 4, so that means the 2 is just on the 4. It is not on the negative sign. So we write that negative sign. We could write a bracket now, times 4 times 4, so that would be negative 16. It's different if there is a bracket around the base. Then we actually multiply the base times itself twice. So this would be positive 16. And I can write a positive in there just to clarify that. So be very careful. This talks about looking at the exponents and the negative signs on the base. Okay? If it's not in a bracket with the exponent outside the bracket, then you only multiply the positive base. Okay? Next one, 6 to the power of 2 is 6 times 6, which is 36. 2 to the power of 5, 2 times 2 times 2 times 2 times 2. So let's do that. 2 times 2 times 2 times 2 times 2. And I'm going to write it down below because it's kind of squinchy here. Equals 32. Some of you will have buttons where you can put your number in on your calculator. Well, that didn't work. Oh, I know why. Yeah. So some of you will have a button on your calculator that looks like y to the x. So you might want to use this one to play around to figure out exactly how you put it in. I have that. What I'd have to do is type in 2, hit the y to the x button, then hit the 5 and then equals. Okay? For really big exponents, that becomes useful. 5 to the 3, 5 times 5 times 5, which equals 125. Okay? Now, when we have addition and subtraction, we have to do each of the exponents separately and then add them. So, remembering our BEDMAS, which we're going to revisit again later today, we do BEDMAS stands for brackets, exponents, multiplication and division, and then addition and subtraction. So we have to do our brackets and exponents first. So we would solve these exponents. So here we'll have 2 times 2 times 2 for 2 to the 3, plus, and then in brackets, 10 times 10. Now, some of you are saying, do we have to put the brackets in? Well, no, you don't. I like to because it really clarifies what's going on. So brackets often become our friend in math because they help us, kind of sort out what's going on. So 2 times 2 times 2 is 8, and 10 times 10 is 100, so this would be 108. Okay? Similarly, when there's a subtraction, so I can go 10 times 10 times 10 minus 3 times 3 times 3 times 3. 10 times 10 times 10 is 1,000. The neat thing with the exponents of 10, powers of 10, is just look at the number of the exponent, and that's how many zeros you're going to have. Okay, so I have 10 to the 3, so that will mean I have a 1 with 3 zeros. And then I have 3 to the 4. So 3 to the 4, I get 81. So 100 minus 81 equals 19. Okay, so just remember your order of operations. Do each exponents first and then do your adding and subtracting. So here, watch what's going on. The negative sign's outside the brackets, so it's 2 times 2 times 2 times 2 plus 3 times 3 times 3. Notice I put brackets around each just to kind of sort it out. 2 to the 4, 2 times 2 times 2 times 2 is 16, so I'll have negative 16 plus 3 to the 3 is 27. Now I'll use my integer rules. I have more positives and negatives because 27 is positive and 16 is negative. So now I know my answer will be positive, and I'll just simply subtract those two. So I will get 11. Okay. Now, the same rules apply when it's a decimal. You're just going to go 5.2 times 5.2. So 5.2 times 5.2 equals 27.04. Okay. Alrighty. I'm changing my color of my pen just to kind of clarify what's going on here. So, oops. Here I have 3.16 squared, so that will be 3.16 times 3.16. Just because they're decimals does not change the way you deal with them in terms of exponents. And I will get a lot of decimal places. 9.98. Oops, that's a weird looking 8, Mrs. Finley. 9.9856. All right. Now here, take a look at it. Is the negative sign in brackets? No, it's not, so it's going to be separate. And we'll have 5 times 5 times 5. So negative 5 times 5 times 5 is 125. Okay. At the end, I'll let you see the whole page, and you can, or I'll do it in sections. You can screenshot it if you like, or pause it to write things down if I'm going too fast. Now, when it's a fraction, same thing. 3 over 4 times 3 over 4. Now we remember our fraction multiplication rules. Fraction multiplications, it's top times top, bottom times bottom. So top times top, 3 times 3 is 9. Bottom times bottom, 4 times 4 is 16. And ask yourself the question, can we reduce it? No. So this is our final answer. Now don't let it scare you if there's 3, if it's to the third power, we can write that out as well. And again, it's top times top times top, bottom times bottom times bottom. Don't let the fact that there are 3 fractions mess you up. So now on the top, we're going to have 2 times 2 times 2, which is 8. And on the bottom, 3 times 3 times 3, which is 27. Ask yourself the question, can I reduce it? 8 and 27 have no common factors, so I am done. And here, again, it's another decimal. So it's 0.5 times 0.5 times 0.5 times 0.5, 4 times. So 0.5 times 0.5 times 0.5 times 0.5, and I get 0.0625. The rules for dealing with exponents don't change just because they're decimals or fractions. It's the same procedure. Trust yourself and go for it. Last few examples. Now, if we have something to the 0, this is a special case. So the exponent is 0. Anything to the power of 0 equals 1. Okay, so if I have 7 to the 0, it equals 1. If I have 5 to the 0, it equals 1. If I have negative 5 to the 0, it equals 1. If I have negative 2 to the 0, but look, the 2 is not, the negative sign's not in the brackets, that would be negative 1. Okay, so be careful about that. Because some of your calculators might not approach it the same way, okay? But anything to the 0, or any exponent to the 0, is equal to 1. So that's a special case, okay? Negative 2 to the 5, so my negative is outside, so 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5. 2 to the 5 is 32. So it would be negative 32. Here, my negative is inside the brackets, so I'm going to times the negative times the negative. Remember our integer rules, if it's an even number of negatives, it's going to be a positive answer. 0.7 times 0.7 is 0.49. Okay, well, hopefully that's a lot of good practice. I'm going to just scroll up. If you want to take a screen cap or pause to write things down, you can pause there, write down the notes. Same thing here, pause now, write down the examples. And then here, pause and write down the examples. So you've got some assignment to do, a bit of practice, and then we're going to tackle order of operations.